these notes are going to be all about finding and calculating the percent composition. I like to think of percent composition kind of like if my family is going for a boat ride on a small boat. We might only have 4 people, but my dad is probably going to take up a lot more of the mass than I or my sister would. So his percent composition out of all of us is a lot greater. And this is going to be the same thing that we're talking about when we're talking about elements. Some elements are going to weigh more than others. So the formula for percent composition is up here on the board. You take the percent composition, it equals the mass of the element times the amount of that element, or in other words, the atomic mass times the amount, and you're going to divide it by the molar mass. Then you multiply by 100. So we'll do an example, and we are going to find the percent by mass, that's another way of saying the percent composition, for CF3. So what I'll do first is I'll separate carbon and fluorine into their own groups. Then I'm going to use this formula. So the mass of carbon is 12 grams, and the mass of fluorine is 19 grams. I'm going to multiply that number times the amount. So in this formula, I have 1 carbon, and over here I have 3 fluorines. Then it tells me to divide by the total mass, or the molar mass of CF3. So if you add up 12 times 1 with 19 times 3, you should get 69 grams. And that is the molar mass of CF3. Then it tells me to multiply by 100, because this is going to be giving me a percent. And then all I have to do is do the math. So 12 divided by 69 times 100, and 57 divided by 69 times 100. If you do that math, this problem is 17% carbon and 83% fluorine. I did round those off a little bit. The numbers should even out to be about 100. It'll vary depending on if you round it or not. But you should end up close to 100. And that's telling us that most of this molecule is made up of fluorine. Most of its mass comes from fluorine, even though it might be different. For example, CH4, most of its mass comes from carbon, even though there are more hydrogens. We'll do another example. You might want to try this one on your own. Pause the video and then come back to it. But you'll do the same thing for this problem. You'll have carbon and fluorine. You will have the mass of each element, so 12 grams and 19 grams. You'll multiply by the amount, which is 18 for fluorine, and then you'll divide by the total mass. If you add this number with this number, you should get 414 grams. Then you'll multiply both those numbers times 100. And for carbon, you should get 17%. And for fluorine, you should get 83%. So the percents for these two formulas were the same, which brings up our next topic, which is empirical and molecular formula.